Hello everyone, I'm Samuele Stefanoni and I'm a software engineer of SMH Technologies. This is the first video of a video lecture series which will present you FlashRunner 2.0 technology. FlashRunner 2.0 is a breakthrough technology especially designed to meet the highest requirements in production environments. It has been designed with the concept of production efficiency in mind and has been tailored especially for in-system programming solution. But before going deep into FlashRunner 2.0 technology, I want just to show you at a glance what in-system programming is and why so many EMS switched in the last 15 years from pre-programming solutions into in-system programming solutions. In this slide, I will compare in-system programming and pre-programming. What does it mean in system programming? It means to put the flashing process in line, in production line. And usually flashing process is achieved at the end of the line. So at the end of the line usually we find in-circuit test or functional test. So FlashRunner 2.0 usually is integrated inside in-circuit test machines or functional test machines. What does it mean? It means that in this case the flashing process time is critical for the production line throughput, and this means also that the flashing process in in-system programming methods must be fast enough not to create a bottleneck into the production line. Given this, what are the benefits of using in-system programming solution? Maybe the most important benefit is that it gives to the production environment much more flexibility. So let's suppose you are going to production, you are producing hundreds, millions of boards, and at a certain time the R&D discovers that there's a bug in the firmware which is now being flashed inside all these boards. With in-system programming, you can easily update the latest firmware release, which contains the bug fix, update the flashing solution, and update so the production line to produce all the remaining boards with the bug fixed version of the firmware. Another example is that you can, for example, do customizations on the board being produced, like for example doing serial numbering, put MAC addresses, all information that must be unique inside the device under test. All these features made in-system programming the best choice for EMS manufacturer in the last 15 years, and that's why by designing FlashRunner 2.0 our key concept in mind was the programming speed. So by choosing FlashRunner 2.0 you will be sure that we will meet the higher requirements provided by the silicon producer which are placing on the market programmable devices. And around the programming speed topic we have an orbit of other really important and needed requirements inside a production environment. Among them, the first I want to speak about is the channel parallelism and modularity. Why channel parallelism is important? Because nowadays boards are becoming every day more complex. And this means that they have mounted on board, more different chips which need to be flashed. Of course, flashing them in parallel brings benefits in terms of the overall cycle time and once again less costs. That's why FlashRunner 2.0 has been designed in order to flash up to 16 different devices at the same time. Another important feature is the ultra-compact design. What does this mean? FlashRunner 2.0 can proudly be stated that is the best product in terms of channel and required space ratio. So it's very small and can be easily integrated inside whatever AT machine, in-circuit test machine, functional test machine, or inside fixer. New friendly user experience means that we created software tools which simplify the process of setting up a new flashing procedure. Every day, production engineers met difficulties, met the challenge to set up new production lines. They change quite often from project to new other projects, and you have to set up to rebuild the flashing process from scratch. So having a simple tool like FlashRunner has through the Workbench software let them be able to simplify their own lives and create easily in 7 steps a new working project. Finally, anti-piracy and security features. Nowadays, cybersecurity topic is becoming more and more important. FlashRunner 2.0 is able to face this challenge by providing encrypting functionalities on data in order to avoid tampering or cloning, and other features like, for example, dump and compare, which let you be able to check it out if your flashing process has been done correctly as you expected. What's under the cover of FlashRunner 2.0? First of all, there's a system on chip. So there's a chip which combines together microprocessor and FPGA features. What does this mean? Microprocessor is used to run all the flashing specification, all the flashing routines from the high-level perspective. The FPGA instead is implementing the protocol state machine, and so is driving finally the signals on the output ISP connector. What does this mean? Combining together on the same die, these two features result in a higher bus and once again faster programming speed. Microprocessor has a dual-core ARM-based hard processor system at 800 MHz working operation frequency. This means that under the cover we have a real computer system, and as every computer, it does have also 1 gigabyte DDR RAM memory and a storage memory. In our case, the storage memory is implemented by using a micro SD card and is used to store all your project files, like for example driver, project, or the firmware. Since 2020, every FlashRunner 2.0 is coming by default with 64 gigabytes storage memory, but can be increased depending on customer requirements up to 256 gigabytes. Last, communication frequency. As every standard communication protocol, especially serials protocols, are going from 1 MHz usually up to 20 MHz, FlashRunner 2.0 has been designed to meet this full range and is providing up to 25 MHz communication frequency from FlashRunner to target device. Communication features can be divided in 2 categories. The first is communication from FlashRunner to host, and the second is communication from FlashRunner to target device. Communication to host can be achieved with 3 methods: by using a real Ethernet LAN connection working up to 1 gigabit per second, by using the USB connection, which is actually a USB to UART connection, which makes simple communication setup, and so you will be able to communicate easily with whatever software for UART management. And the last one is the AT connector. This is used for the that we call the standalone mode, and by simply driving some pins on the control connector or reading back the value high or low of some pins on the control connector will let you be able to communicate with FlashRunner 2. So you will be able to select a project inside the storage memory, trigger the project execution start, and read back the project execution result. From the communication between FlashRunner 2.0 and target device perspective, each channel is having 8 digital I/O lines, which are needed to implement this serial protocol. Each channel has 2 programmable output voltages, like for vPro 0 and vPro 1. vPro 0 is tailored to power supply the microcontroller, so it ranges between 1.8 and 5.5 volts, and vPro 1 power supply has been designed to power supply the entire board, so it ranges from 6 volts up to 13.5 volt. Every power supply is completely independent, and you have also the possibility to read back the current and the voltage, so you can do measurement and double check that the power supply is really okay. A brief introduction on the software, which we will face in next video lectures. The most important things to remember is that FlashRunner 2.0 nowadays support more than 10,000 devices, and the same device list is applied to all the products belonging to FlashRunner 2.0 series. DLL integration is another must inside the production environment. So we provide, together with the software package, library which called DLL for C and C++ integration, which is also working as an interface in order to integrate FlashRunner into LabVIEW or TestEnd application, which are the most common software platforms for the functional test and in-circuit test procedure development. I think that this is enough for the moment. I will cover more in depth other topics in the next video lectures. If you have some comments or you want more information, please write to our email address info@smh-tech.com, and see you in the next video lectures.